So to bring all these things together, what I'd like to do is kind of combine a discussion of all of these different quantum numbers and look at them. So the shape of an orbital is determined by the definition of L. Okay, so that's our second quantum number. Um, quantum number. Our first quantum number, n, is simply going to be assigned based on the row that something is in the periodic table. So if we lay out our periodic table, 1, 2, 3, 4, 5, 6. Okay, so those are all good examples. So your n value is going to be something that you get straight from the periodic table. Your L value is your second quantum number, is going to help you determine the shape of an orbital. So by definition, we have a total of 3 most commonly used orbitals. So if L equals 0, you're talking about an s orbital. If L equals 1, you're talking about a p orbital. If L equals 2, you're talking about a d orbital. Now, the one that's a little bit more complicated is if L equals 3, that is an f orbital. I'm going to introduce the f orbital, but to be quite honest, you really don't talk about it very much because then you're getting into those like lanthanides and actinides and high molecular weight elements, which we really don't talk about very much in a general chemistry class. Okay, so first of all, the s orbital. The s orbital is shaped like a sphere. I've always thought it's kind of the easiest one to remember because of the fact that the word sphere starts with s. Okay, now if L equals 0, then you know that M equals 0 is 0. Therefore, there's only one orientation or type of an s orbital. So what I want you to think about that is, let's say that you've got a sphere, or you have a sphere. Now, if you rotate that in any direction, let's say you rotate it 90 degrees. What does it look like? It still looks like a sphere. Nothing about that sphere has changed. Okay, so that in any direction that you rotate it, it's going to look the exact same. So that's why we only have one orientation, which is that one orientation corresponds to only one m value. Okay, now that's the 1s orbital, the 2s orbital, the 3s orbital. So think about these as these orbitals get successively larger and larger and larger and larger. And what we're doing here is we're looking at where are basically some electrons placed. Okay, now the next orbital set is the p orbital. Okay, a p orbital is shaped like a dumbbell. I'll generally refer to as dumbbell shape. And the dumbbell emerges whenever your L value is equal to 1. Okay, so what does that mean for your M value? So M has a total of 3 different values. It could be -1, 0, or +1. Okay, so now let's look at this dumbbell shape. And what I want to highlight to y'all is the axes. So what we're doing here is we're looking at this single dumbbell shape right here, positioned about a z-axis, positioned about an x-axis, and positioned about a y-axis. Okay, so those are distinct representations. And in each one of these representations, we get 2 electrons here, 2 electrons here, and 2 electrons here. Okay, so that means that we're going to put a grand total of 6 electrons in a given p orbital. Okay, now these 3 different orientations, think about these as basically being, and this is not a direct relationship, but think about the p sub z here that I've mentioned as your -1 value. So that corresponds, that representation corresponds to the m sub L value -1. Okay, your p sub x corresponds to the second. And then finally, your p sub y corresponds to that +1 value. Okay, so that's these 3 different positions, or these 3 different representations in 3D space, correspond to 3 different m sub L values. Okay, now the next orbital that I'd really like to talk about is the d orbital. Okay, so the d orbital is quite complicated. It's a double dumbbell. So in each one of these, we can have 2 electrons, 2 electrons, 2 electrons, 2 electrons, 2 electrons. Okay, so a d orbital can hold up to 10 electrons. Okay, Now, it looks quite similar, and some of these representations look similar to those p orbitals, but keep this straight. This is a double dumbbell compared to a single dumbbell shape. Okay. Now, what this emerges from is whenever your L value is equal to 2. If your L value is equals 2, what does that mean for your M sub L value? Well, that M sub L could have a -2, a -1, a 0, +1, or +2. So the way that I try to think about this is think about, this representation right here as being -2. This is -1. This as 0, this as +1, and this as +2. Now, these are not numbers that you have to keep in mind, but think about this as your M sub L has 5 different values, and how many different ways can we contort this double dumbbell shape in 3D space? 5. Okay. The last orbital is the F orbital, and I've got it displayed right here, and as you can see, this is quite complicated. Each one of these can hold 2 electrons. So all told, an F orbital can hold 14 electrons. And we're going to get into what I mean whenever I'm talking about holding electrons in just a little while. But essentially, an F orbital can hold that many electrons, and it kind of brings that much value to the table. Now, what is an F orbital? Well, an F orbital is one in which the L value is equal to 3. Therefore, your M sub L has how many different values? It could be -3, -2, -1, 0, +1, +2, +3. There are a total of 7 possible M sub L values, and there are 7 displays of the F orbital. All right, so like I said, we're not going to talk about the F orbital quite often, but we'll get into electron configuration in just a little while, and hopefully these different orbitals and number of electrons and where those electrons are will make a little bit more sense. But don't worry, this is complicated. I wouldn't be surprised if you have to watch this over, but practice problems are going to be very helpful for this. Okay, so this shows basically a rundown of that similar information that we were just talking about. So in the event that your N is equal to 3, what are the possible values of L? L can have a value of 0, 1, or 2. And so what does that mean for possible values of M sub L? In the event that L equals 2, well, you're going to be talking about M sub L values that are -2, +1, I'm sorry, +2, +1, 0, -1, -2. So then we have a total of 5 different positions in which we're going to place those electrons. So this is a good representation of all of the information, but in just a little while we're going to be going through electron configuration. I think it will be a little bit more clear once you're kind of doing some practice problems and kind of visualizing some of these atoms. I hope this was helpful. Have a good afternoon.